Hello, this is Mr. Wyrick, and I'm here to talk to you about lesson 5-6, inequalities in two triangles. And this one should really be called the Hinge Theorem. It's on page 371. Make sure you take it down in your notes, the Hinge Theorem and its converse. But basically it states that if we have any two triangles where two of the sides are congruent, two of the sides match up to one another, that if the third side is larger, it's because of a larger angle measure. Or on the flip side of that, if two triangles have two sides that match up, then the one with the larger included angle, that's the one between those two sides, the larger included angle is going to result in a larger third side. The easiest way to picture this one is one that they actually have a question about in there is lifting weights. If I go to lift weights and I have both my arms, they are congruent. They're the same length on this one side here as one another, and then from the elbow up to the shoulder, it's going to be the same length on both sides. So if I have lifted this weight, the distance from my weight here to my shoulder here is a very short distance because this angle here created by my elbow is very small. Whereas if I have this one down here, this is a much longer distance because this is a much bigger angle. It kind of goes back to what we touched on in a lesson before, where the largest angle of a triangle is opposite from the largest side, that kind of same thing. So as I switch arms, as those angles change, this angle becomes a very small angle, this angle becomes a very large angle. If I switch back and forth all the time, it doesn't change the distance here. It doesn't change the measure of my arm from elbow to fingers or from elbow to shoulder. These are always going to be congruent side to side. They're always going to be the same. But when I change this angle here, it changes the distance of what would be the third leg of that triangle coming across. So this is the hinge theorem. They say that because obviously this would be an example of a hinge, a type of lever. And as we move that hinge, nothing else is changing but the position of that hinge, the angle to which that is open, and that makes a difference in the distance of our third side of that triangle. If we have two triangles that are the same, we can either look at the angles, determine which is the largest, and say this one will have a longer side, or we can look at the sides, see which one is a longer side, and determine which will have the longer angle. So that's going to be most of what you are doing for the lesson on this one. If you have questions on this, be sure to ask them when you come into class, and we'll see you then.